Okay, here is another problem where we know the speed of this bucket of water. It is 3.3 meters per second. We know the radius of the string. It is 0. Or of the circular motion. It is 0.8 meters. We know the mass of this bucket of water. It is 4.5 kilograms. Okay, we should ask ourselves what okay, so first of all, let's define the centripetal and tangential axis. So this is the centripetal axis. This is the only one we will need to use right now. And we need to define the forces which act on this bucket of water. So there is a force of string tension. Okay. So there is a force of the tension of the string. We will denote it by T. There is a force of gravity which also act on this bucket. The force of gravity is also directed downward in our figure over here. So both forces, the force of the gravity and the force of the string tension, have the same direction as the centripetal axis. And this is why when you write down the Newton's second law in the centripetal direction, which tells us that the mass of this water bucket times centripetal acceleration is given by the net force in the centripetal direction, so we can rewrite this in the following form. So what is the net force? It's the force of the tension. Its direction coincides with the centripetal axis. And this is the force of the gravity. Its direction also coincides with the centripetal axis. So it's tension plus the force of the gravity. Okay, and this we can solve now for the tension force. The tension force will be MAC minus the force of the gravity. Okay, so and the force of the gravity, we know what it is. So it's minus M times G. Okay, so the only thing which is left is to find the centripetal acceleration. So the centripetal acceleration, we know the equation. It is the tangential velocity squared, v squared divided by the radius of this circular motion. Okay, so or finally we can write down the equation for the tension of that string. It will be m times v squared divided by the radius minus mg. So now we can substitute what we know. We know the mass of this bucket of the water. We know the radius, and we know the speed. And we remember what g is at 9.8 meters per second square. So substituting all the numbers, we will obtain 17.2 newtons, or the answer is D.